Hello, and welcome to today's webinar, What's New in VectorCAST 2018 Test Automation. I am your host, Alicia McCullough. Our presenter today is Jeffrey Fortin, Product Manager, VectorCAST. We ask that you please remain muted throughout our presentation. If you have questions, please feel free to chat them to me throughout the presentation, and we will answer them during our Q&A portion after the demonstration. As you can see, there's also some resources available to you in your experience of this webinar. Feel free to check those out. There's some data sheets and some blog posts and some of our previous webinars. So with that said, I'm going to turn things over to Jeff. Jeff?
Thank you, Alicia. Always great to be here with you all. And today we're going to talk about VectorCAST 2018. So let's get right into it. So here's our agenda for today. And I'm going to do first an overview of what VectorCAST is. And then we'll talk about the new features that have been released in 2018. And then Alicia will lead us in some polling questions. And then I've got a little demo of the features at the end and some time for questions and answers. So that's our agenda for today. Okay, I'm going to start talking a little bit about what VectorCAST is. Some of you on the call may be new to VectorCAST. Maybe you haven't used VectorCAST yet for your testing automation platform. So I just wanted to give you a quick overview about what the objective of VectorCAST is and what we're trying to accomplish with the product. So basically with VectorCAST, the philosophy that we have is to make testing fast, to make tests easy to run, and to test continuously. And with regard to testing fast, what we're trying to do is improve the amount of efficiency that's done through the automation platform to make testing an easier process. Testing overall, especially testing in the embedded software is a very difficult process. Knowing what the test vector should be, getting the right amount of test coverage, being able to understand how to derive the tests from the requirements, implementing those requirements and then testing them properly, etc. It's a difficult process, and especially in the embedded world, that can take a lot of time. And with the embedded world, we're generally coding and implementing software for safety critical and mission critical types of applications. So there's a lot riding on what we're doing, and we have to get it right. There has to be a high degree of integrity with the software that we're developing. So testing is important, but testing can take up a lot of time, and that's what VectorCAST does, is we allow that time to be saved so that you can focus on writing the tests and doing all the difficult work. Let us provide the automation platform to reduce the amount of time that it takes to do the testing overall by using automation. By easy to run, what we mean by that is with VectorCAST, we really want to make it easy for anyone to be able to run a test or to be able to create a test. And with VectorCAST, we can set up tests without knowing anything about the programming language itself. You can simply take a look at the requirements for the software units and plug in the parameters that are needed according to the design. And you can create a test harness automatically without knowing anything about the coding language itself, and to be able to run those tests without knowing how the application itself is run. All of that's built into the platform itself, and it makes it so that there's a better likelihood that anyone on the project could run a test at any time and make an assessment of the quality of the software at that point. If you have a limited number of people who are able to run the test, then that limits the number of chances that a test will be run, and you have fewer points at which you can make an assessment of the quality of the software. So we want the test to run fast, and we want the test to be easy to run. And then the last point here is we want to be able to run continuously. So testing shouldn't be just one phase of your project where you've finished your implementation and now you're going to run through your tests and see what kind of coverage you have or collect some kind of metric that maps, say, the test cases to requirements. Instead, our philosophy is that you really should be able to run the tests, create the tests, validate the tests throughout the entire software development lifecycle, not just the development phase, but actually post-deployment, making sure that the bug fixes you haven't introduced any regressions in the software, and to be able to do that continuously throughout the entire software development lifecycle. So quickly, that's our philosophy: make testing fast, make it easy to run, and to be able to have the ability to test continuously. So in doing that, what we like to do is give this little rubric for customers, and in this rubric, these are 4 example metrics that could be used to sort of analyze where you're at in your test automation voyage, if you will. So in test automation, one thing you'd like to be able to do is take an assessment of how long it takes your test to run, so time to test. If you have a low level of automation, then it's probably taking weeks, maybe even months, to be able to complete all of your tests. But with automation, we can reduce that down. Automation not only allows the test to be run automatically, but we can add some intelligence into the testing to make it so that we run the tests that need to be run and not just all of the tests. So VectorCAST has built within it the ability to understand the code and understand the interaction of the tests and the code, and to be able to run those tests in a more efficient way, which reduces the total amount of time it takes to run all the tests. How often do you need to run the tests? If your tests take long to run, you tend to run them less frequently. You don't want to take up cycles in the development just to be able to run tests. So if it takes a long time, then you tend to run them very infrequently. If you're moving to an automation platform, then what you'd like to do is get to the ultimate, whereas every software change that you make as you check it into your CM system, you'd like to run the regression tests and make sure that that change hasn't introduced any bugs in the system, that the level of quality is as high as it was before the change was made. Who can run the test? I talked about this on the previous slide a little bit. So if there's only a small group of people, there tends to be sort of a QA department, and that QA department, is, quote, responsible for tests. Well, what that means is that you're limiting the number of people who can actually make an assessment of the software. And by limiting the number of people, you have fewer chances of finding bugs, and that increases the risk that you have on the development project. So you'd like to get it to the point where really anyone can run a test. If it's as simple as pushing a button, then people will push a button and will make an assessment at any time on the quality of the software. And then overall, the level of automation. If your tests are highly manual, then it becomes difficult to automate those tests. And what you'd like to do is get to a point where maybe you can hit the ultimate, where every single test can be run automatically. Or at the very least, you'd like to be able to interact with an automation system. By that, I mean if there are some things that require a mechanical interaction, like a reset button, or to be able to interact or be able to see a display, for instance. There are things that can be done with automation at the physical level to make it so that these tests can run automatically without human interaction. So even if there are things that need to be done from a physical point of view, we can introduce automation on the physical level to be able to interact with the automation that's happening on the test servers, and combine those two together, and we can get to a very high degree of automation on the platform. And when you have that level of automation, overall, that just makes the testing go much smoother. The other thing you can do from an automation point of view is really plan for test. So when you set up your software, you set up your architectures, you set up your test environments, you set up your test harnesses, have a mind to how it is that you're going to be able to test the system. And when you develop the software and go through that, you know how it is that you're going to be testing that software. Don't get to the point at the end where you're at the critical moment where the software has to be tested, and then you realize that you've got to put in some test infrastructure that is going to take a lot of time to invest in that infrastructure. Do that work up front. Have a plan in place for how are you going to test all of the software. Okay, so those two slides really are about our philosophy and about how you should be assessing your software development process from the point of view of test automation. All right, so let's talk a little bit more about the software development process itself. The software development process is often referred to, especially in the safety critical industries, with this V model. It's the classic software development model. Sometimes it's called waterfall. Now, I know a lot of you have moved away from waterfall and are really doing more of an agile process. So just look at this V model as a small v for the work that you're doing. If you're following an agile process, it means that you're writing at the beginning some user stories, let's say. And those user stories are telling the developers, what it is that they should be implementing. And you're also creating some acceptance criteria for those user stories. So you've got the user story, you've got acceptance criteria, and really that's the basis for what's on this V model. So instead of going through the entire requirements for the entire system, you're going to break it up into little chunks. And those little chunks are sort of mini V models, and then you're going to be able to run through that cycle each time. So no matter what kind of software development process you're going through, whether it's classic waterfall or a more modern agile process, this model still applies. And you can see where VectorCAST fits into the model. We're really on the right-hand side, which is the testing side of it and the validation side, and also to some degree on the coding side as well, especially with the static analysis tools that we have built into VectorCAST. And then you can see the circle going around, which is the continuous, complete, and correct. So let's talk a little bit more about those three. So with just breaking down the V model again, you can see that there are a number of tools that Vector supplies, and VectorCAST is one of the tools that Vector offers overall. Some of you on the call may be coming from, maybe using other products from Vector besides VectorCAST. Maybe you're using Canoe, VTest Studio, or one of the other Vector products. And what we've done here on this slide is really sort of mapped in some of the Vector products and how they fit into the V model. And you can see how they integrate in all of the various forms of testing. VectorCAST is there. VectorCAST unit testing comes along at the bottom of the V model, and you can move up to the top to VectorCAST QA. And then in the middle is sort of both unit test as well as the system testing from QA. And you can see over on the side is VectorCAST Analytics. And Analytics is a dashboard program. We'll talk a little bit more about that. That dashboard is showing metrics in the testing process itself. And it really goes throughout the entire software development lifecycle for all testing phases. Okay, so I said we'd talk a little bit more about the product line itself. And you can see this is just a snapshot from our website. If you haven't looked at our website lately, please do. It's been updated, and we're rather proud of how it looks. But here you can see a page of all of the products that are in our product portfolio. So we have VectorCAST QA, which is the system test automation platform, and then the VectorCAST C++ and Ada. Those are our two unit test platforms. If you're using C or C++, then you would choose the C++. And of course, Ada is for the Ada package. And then over on the bottom left is Analytics, which I just talked about. That's the quality metrics dashboard, web-based platform that allows you to see all your testing metrics. And then for static analysis, we have an implementation, a graphical viewer for Lint, and it allows you to do static analysis on your code. So if you're doing some sort of code checking for making sure that you're hitting your rules, for instance, for MISRA, if you're in the automotive industry, you'll know what MISRA is. And it allows you to check the coding statically and make sure that you're following all of the coding conventions that are required by your project. All right, let's get into a little bit of detail about how the unit test tools work. So this is VectorCAST C++ as well as for Ada. And what we're doing here at the unit test level is we're actually testing the code at the functional unit. So if you have a C module, let's say, in that C module there are functions that are defined, and those functions have parameters. So what we do with VectorCAST is we integrate in with your compiler, debugger, target environment, whether that target environment be a target board, as I'm showing here, or the host-based environment. We'll integrate in with your build system, and we'll take the source code and we'll parse it. And from that parsing, we'll actually understand the types of the parameter types that are being passed into all of the functions. What that allows us to do is create a very intuitive test generation window. And even if you are not a C or C++ coder or an Ada programmer, you can create test cases right from understanding what the requirements are for the design of that particular unit. So if you've got some requirements that say, hey, you need to have a test case that shows this unit being called with the maximum value, the minimum value of an integer, let's say. And then you've got some, let's say, enumeration types, where you've got some test cases where each one of those enumeration types has requirements behind it, where if I pass in one value of the enumeration, the function should return, a second value. All of those things can be just plugged in. We've got some very intuitive drop-down menus that know the types of all of the parameters and be able to select the legal range for those parameters. So we do all that parsing automatically. It saves quite a bit of time. And we automatically create a test harness based on those test cases that you've just created. So no coding is required here. You don't need to understand the language itself. We will generate that harness, and we will compile that harness with the environment that you're using for your software development. So we work with a whole raft of different compilers and debuggers, and we can create a test harness in the environment that you need for your testing. Okay, so that's a little bit about how the unit test tool works. We'll move over to the system test tool. And with the system test tool, now the granularity has moved up. So with unit testing, we're testing individual software functions. Now we're testing an entire application. So with QA, we're doing system test and testing the interface to the entire application itself. So we call the application then runs through a number of test cases. Let's say that the application takes some arguments when you call it, and you'd like to be able to test those arguments and ensure that the application behaves as you expect. So those test cases you would have already. You know how it is that you want to call your application. And what we're doing with QA is we're automatically embedding all of the information into QA for how to create that application with your build environment, be able to run those test cases automatically, and have the ability to understand how those test cases are interacting with your code. What I mean by that is we can actually trace the coverage of execution as you run each one of those test cases. We essentially put little breadcrumbs in the code, and as the code runs, we are able to see the paths that the code is taking through the software. And we create a report for you that says what the percentage of test coverage you have for each one of the test cases that you run. That's very, very helpful because often folks have system tests that they feel are very complete and comprehensive. Probably they're using them as an acceptance test. So this is used to sign off the software. The software can't be delivered until you pass the acceptance test. And the people who write the acceptance test also often feel that test is very comprehensive. And it's very curious and interesting too, when we run QA for the first time and we take some coverage metrics and we pass those back, and you find out that those comprehensive tests that you were running were only touching about 20% of the code. It's very enlightening. And that's what you get with testing metrics. It's actually showing the true colors of the software and showing you really what is the quality of the tests that you're running, what are the test metrics that can be collected and make an assessment of where you're at on quality. Okay, that's a little bit about what QA is all about. And then finally, analytics. I mentioned this is a web-based dashboard. And with this dashboard, we can take a look at the different testing metrics and correlate metrics one to the other. So you can see some heat maps that are down at the bottom. Those heat maps are great because they allow you to really focus the limited resources that you have in areas that really need some help. So you may have a heat map that correlates the amount of statement coverage that you have versus the amount of statements that are in a particular function. So the top left-hand corner of the right side heat map is red, and that means that there's a unit there, a module that has a large number of statements in it and has a very small amount of coverage on it. So if we wrote some test cases, the chances are we would very much improve our coverage if we focused on test cases that are associated with that module. Whereas if we wrote test cases to some of the modules that are completely green, we're not going to be adding at all to the coverage. Those tests may be very important, but if our objective is to get to 100% code coverage, then what we want to do is focus our activities on test cases that will actually improve the coverage that we have in the software. The nice thing about analytics is that it gives me a comprehensive view not only of an individual project, but of multiple projects. So if I have a project that's distributed throughout the world, let's say I have a development team in North America, a development team in Europe, and let's say another team in India, I can combine all of the testing efforts for all three of those into one dashboard. And if I'm a project engineer, I can get an overall assessment of the quality for all three of those teams. And I can drill down into each individual project and each individual module and, in fact, each individual function and be able to see an assessment of the quality at that level. So it works for all levels of the project team to be able to see where they're at. When you have these analytics, you make them available to everyone, that everyone really gets to participate in the quality process, be able to notice patterns, and be able to take action to improve the quality of the system. Okay, so we're done with our VectorCAST overview, and we'll move now into some of the features that we've added for VectorCAST 2018. Okay, our system has, just going to do this directly. Yes, okay. We had this problem last time where
you got it.
The platform changes the slides on us automagically. So that's a level of automation we don't need. Okay, so this is a screenshot of VectorCAST 2018. And in it, if you're familiar with the older versions of VectorCAST, you'll notice it has a nice, fresher look and feel to it. And we think it makes it, by that look and feel, makes it a little bit more intuitive to be able to see what's there, see how the menus are drawn, be able to find the information more quickly. And also, we've done some things to make it so that some of the examples we have, run, associated with the phases that you've got, and be able to just go right to the information that you need. In the demo, I'll show you this home screen and show you some of the changes that we've made to it. Some of the things that we've done, for instance, is to if the development host that you're working on has access to the internet, you can actually get live feeds from our VectorCAST website to be able to see news and information, be able to see the different pieces of information, and I'll show you that during the demo. So updated look and feel, a little bit cleaner look to it, and I think a little bit more of an intuitive interface as you click through the menus. All right, so at the beginning I said we would take a look at that circle that was going around the V model and look at each one of these independently. So what we've got with VectorCAST 2018 is we're really focusing in, that's a word, on correct, complete, and continuous, making sure that your code is correct, making sure that your code is complete, your testing is complete, and making sure that your testing can be run continuously. Alicia at the beginning mentioned that there are some resources that are also sent to you with the webinar information, and there are 3 blog posts that are included in those resources, and those 3 blog posts correlate to each one of these. So we have a blog on correct, we have a blog on complete, and we have a blog on continuous. And just to quickly go through what we mean by all of these, what does it mean for your code to be correct? This has the notion of, what does it mean for the code to be right? Does it just mean that it compiles? Does that mean that the code is correct? Or does it mean something more concrete, like does the code actually meet the requirements? So in the blog post, we go into a little bit further about what we mean by that. But VectorCAST is set up to implement the notion of code correctness. And really, code correctness is the fundamental basis for high integrity software, and that's what VectorCAST is set up for. Complete is a really interesting one. I enjoyed writing that blog post because software is so complicated that it is almost impossible, except for a very trivial piece of software, to completely test it, because there are too many permutations and combinations that run through software. So what you really mean by completeness is that one criteria is that you've met the release criteria, right? So the release criteria says, we have to have a certain level of coverage. We need to implement these requirements. We need to integrate in with this legacy software. So we have a list of things that we want to do, and once we do all of those things, we consider it to be complete and to meet the quality standards that we have. So software completeness is always a trade-off, and we're always balancing off the effort that it takes to do the testing with the risk that's associated with the use cases for the application. And then continuous means that we have the ability to do testing both in all phases of software development, as well as literally continuously. So are we able to do a test and reassessment every time we make a change to the software? So those are the VectorCAST themes: correct, complete, and continuous. Okay, now we'll dive into a few of the features that we've improved in 2018. So ProPoints was actually introduced sort of midpoint in the 6.4 release. So we had sort of an early access release of ProPoints that a lot of folks liked, and in fact, last year at this time, we were nominated for an award at Embedded World, one of only 3 companies of all of the ones that were participating in Embedded World to receive a nomination. So we're really happy about that. ProPoints is a technology that allows you to take white box testing really to the next level. What we mean by white box testing here with ProPoints is that we're actually inserting little pieces of test code into the software itself and be able to do some things like inject faults, to be able to debug some hard-to-repeat race conditions, all of these things. But the ProPoints are in a nice overlay fashion. So you might have done this before. A good example of a ProPoint you might have implemented yourself is the good old printf, right? So you have your source code. Gee, there's some information I'd really like to get back from the software, so I'm going to add a printf to my source code, and I'm going to get some debug information about what's going on in the software through that printf. The problem with the printf is, of course, is that you're actually changing the source code itself, right? So now you have the production source code and you have this debug source code. You've got to do all the configuration management around it. Maybe you're going to wrap that little printf with some if-defs with the classic debug flag on it. So if the debug flag is set, the printf will be compiled in, and if the debug flag is off, it'll be out. And the real problem with that is, suppose you forget to remove that macro and that debug code ends up in the delivery system itself. That's a bad situation. With ProPoints, it's an overlay system, okay? So you've got your source code, and we overlay on top of it the ProPoints, and you're guaranteed in that way that those ProPoints won't enter into the production stream because they're part of our test harness, and our test harness doesn't get released into production. So it has that nice overlay feature to it. So there are a number of other ProPoint use cases that we have. But what we did with 2018 is we actually extended the functionality of probe points so that it could be used programmatically. Probe points were already integrated into the GUI itself, the VectorCAST GUI, but now you can actually manage the probe points programmatically through an API. And the use case for that is customers often, especially for system tests, have developed their own in-house system test generation software. Okay, so this is in-house software that is very tuned to their application. It knows what their application is. It can read the requirements and be able to automatically generate test cases from those requirements. That's a very sophisticated piece of software. It takes a lot of investment, in-house investment, to be able to create that infrastructure, and folks want to be able to reuse that in their system testing. So we had a customer, and they wanted to be able to use this in-house system test tool, but integrate it in with VectorCAST so that they could use VectorCAST to generate all of the test points and be able to inject these faults, be able to actually call parameters of the software itself through the probe points. And so what we did is we provided this API that allows them to use their in-house test tool, but integrate it in with VectorCAST to automatically create and manage all of the probe points to implement their test cases. It's a nice system. Component coverage. So with component coverage, what we're doing here is we're really optimizing the automation for the advantage of being able to collect coverage information in environments that are very resource limited. The typical example is a application that's using up, a large percentage of the memory resources that are available on the target. Let's say they're taking up, 98 to 99% of the available memory just with the application alone. Well, in order to get coverage information, we have those breadcrumbs that I talked about that get put into the test harness, and that's what is what is allowing us to collect the coverage information. Well, if you're already at the near limit of the memory, when you add these breadcrumbs or this test harness into the mix, you might exceed the amount of memory that you've got available on the target environment. But you've still got this requirement to do coverage, and how are you going to do both? Well, what we do is we use the power of the automation platform to make that simpler, and you can actually break the software up into pieces, automatically run all of the pieces for the test cases, and be able to collect all that information automatically into a single test report. So that way you can accomplish your goal of getting all the coverage information even when you have very limited resources on the target. And then improvements for collaboration and automation. Both our analytics platform as well as our overall enterprise testing platform are really set up for collaboration and automation. And we've done a number of things in 2018 to improve all of that. The Jenkins platform is a very common continuous integration platform and can be used for continuous test. So what we've done there to make things easier is on the Jenkins site itself, we have a number of plugins that allow you to integrate in VectorCAST into the Jenkins system and run all of the testing jobs that are set up for VectorCAST in Jenkins itself. Now, the plugins are really meant as a starting point. It gets you going. It makes it so that it's easy to get started. And then once you're started, you might want to do some additional work on the integration to match up with some of the things that you might be doing. But really what the plugins do is just get you started. You don't even really need to know much at all about Jenkins in order to use the automation platform and just get started with using Jenkins with VectorCAST. And then you can see over on the side some of the other integrations that we've put in, and you'll be seeing some more. We're going to do get some information out that provides some more information about these integrations that we've done, especially the ones here that are listed over here on the side. Okay, coupling, analysis, and verification. This is really meant for our avionics customers. In avionics, there are requirements in both DO-178B, but especially in DO-178C, that spell out coupling analysis requirements that have to be done on applications. We've used the power of our coverage harness to be able to collect this information, and we really do it in two phases. We have a static analysis part that identifies what the couples are in an application. By a couple, we mean an interaction that's happening between two modules in an application. So it might be a data couple, in which case there's a global data item that's accessed between two modules in the system, or it might be a function call that's a public function call that is called between components in a system. And what we do from static analysis is we just read through the code and we tell you what all of the couples are in the system. But if we had only that, it would be extremely valuable, because what that does is telling you how the code is actually implemented, and you can use that to validate that against the design. So if the design says that there's a global data item and this global data item should be used in these 3 components, but when you run the static analysis you find out it's actually used in 5 components, then that should cause you to take a look at what got implemented. Is that correct? Should those other 2 components actually have been using that global data? Is this a bug in the code? And you'd like to be able to know all these things before the code ever gets deployed. So beyond the static analysis, which already has a tremendous amount of value, we then use our coverage instrumentation to be able to run through the requirements-based tests and then see how those couples have been covered. So if it's a data couple, for instance, we can see the order in which the access to that data couple has happened, and you can say, okay, in this module the data item was written to, and then in the other modules it was read. So that seems like a normal order of things to happen. But if it turns out that we have a data item that was read before it was ever written to, that gets flagged and says, this needs further analysis. Is this correct behavior of the code to read this data item before it's ever been written to? And the answer could be yes. For instance, it could be a register value that's a clock, and the data that's in that register value is being supplied by the hardware. So it's not an item that you would write to. So it could very well be that it's fine, but it allows you to take a look at it and flag it as requiring analysis. So data coupling and analysis, data analysis and verification is one of the things that we've done for our avionics customers, and it provides a tremendous amount of a tremendous time saving, because doing this manually is very painful, and going through the process through the automation system really saves quite a bit of time. All right, so just overall our 2018 plans. If you're already a VectorCAST customer, then you have access to our download site. And on that download site, you'll see the downloads that are now available for 2018. In fact, I think just last night we released the first service pack. So I wanted to talk to you a little bit about service packs. Previously, we had used either letters or dot numbers to indicate an update. So we had, like things like 64A, 64B, 641, 642, etc. Now for the 2018 series, you'll see service packs. So the updates to 2018 will say Service Pack 1, Service Pack 2. And we've done this because we think this is a more common industry practice, but also the other product lines within Vector use this nomenclature as well. So we wanted to align with how the other product lines showed their updates as well. So those are the plans for 2018, and you're going to see more updates along the lines of making tests easier to run, making it so that anyone can run the tests and be able to run continuously. And those are the things that we're going to focus on for 2018. Okay, so we're at the point where Alicia is going to run through some polling questions for us.
Okay, great. Thanks, Jeff. Okay, the first polling question. Are you currently using VectorCAST? Yes, no, or planning to? Go ahead and plug your answers in. And we are getting great questions coming in, so please feel free to continue sending in your questions. Okay, let's go ahead and see what the results are. Any results? Oops, what's happening here? No, not sure what's going on.
Yeah, Alicia, I'm not sure, but on my side, I didn't see the questions being displayed.
Yeah, I know. I've had to push all the slides forward myself as well during your presentation, so I'm not sure. Let's try this. Okay.
Okay, there you go.
Let's hope everyone can see. All right. Yeah, you can see that, but others aren't seeing that. Okay. So, okay, go ahead and plug your answers in. Sorry for that little technical difficulty, but we got it. Okay. All right, we're going to go ahead and go on to the next polling question. All right, what types of testing do you do? Unit testing, system testing, integration testing, a combination of the above? Go ahead and plug your answers in. Great. Okay. All right. We'll go ahead and go to the next polling question. Make sure everybody's done. Okay. And all right. Okay. The next polling question. Do you test on the target hardware? Yes or no? You can go ahead and plug your answers in. Okay. Great. Okay. Looks good. Okay. I am going to go ahead and turn things back to Jeff. Jeff?
Okay, so some interesting answers there. So a pretty even split between system testing and unit tests. And target hardware had an overwhelming response to it, so that's great. That's exactly what VectorCAST is meant to do. All right, so now I need to push a button, and if all goes well, we'll be able to see a demo here. Okay, should be coming up now. Good. All right, so on your screen you should be seeing VectorCAST, and what I'm going to do is I'm going to go to this screen right here first, which is the screen that you see when you sort of log in first. It's actually this screen right here. And you can see it has updated look and feel to it. We've got some clicks over here on the right to be able to start using VectorCAST. If I had any recent environments, they would have shown up over here. I have access to the documentation down at the bottom. And one of the things I wanted to show you was these feeds over here. So there's the star button right here. And when you push on that, you can take a look at the different things that are happening within Vector. And for instance, there's this webinar coming up. In fact, it's right now, as a matter of fact, on what's new in test automation. So you can see that this is a live feed. Of course, wherever this is running needs to have access to the internet, so it's not going to work if you don't have access to the internet. But if you do, it's really nice to be able to see some of the neat things that are happening right there, and also we have access to the community board, be able to see some different things, be able to take a look at white papers that are available, that kind of thing, all available right here. Of course, you can go to the VectorCAST website, but this is actually drawing in from the website itself. Okay, so that's a little bit orientation about that. I wanted to go to the examples here, so you can see that we've organized the examples, and some of the names have changed a little bit here that we think make it a little bit more intuitive. What you'll see here is the enterprise unit testing over here on the side, and that's really testing for enterprises. And what we mean by that is being able to test multiple unit test environments, I should say. So over here on the left-hand side is be able to create individual unit test environments, and then with enterprise testing, we're really pulling all those together and being able to run all of those environments together as one enterprise. And then you've got the system testing example I mentioned about static analysis. You've got an example there. And not to forget Ada, of course. It's an important part of what we do. There's a tutorial as well for Ada. So the tutorials themselves have been updated, and yes, you can see there's a little bit of updates with some of the names of them, but they're right there on the examples page. Okay, so one thing I wanted to do is talk a little bit about ProPoints. Now, it's a little bit difficult to demo of an API, but what I wanted to do is show you from a ProPoints perspective some of an addition that was put in, and this is the ID unit here of the ProPoint. I can go to the ProPoint editor itself, and you can see that I've got a ProPoint that's inserted right here in the code. And what I'm doing with this ProPoint, if you remember, these are little snippets of code where I can actually inject some faults, be able to put some debug information in, and I've got a ProPoint defined here by saying, hey, look, I've got this code here that sets this particular part of a structure to pi, but I want to change that to cake. Maybe I want to do that because maybe that's a bad value, and I want to see what the software would do if cake were put in there instead of pi, which is what the code would normally do. So that's just an example of what a ProPoint could be. And you can see that from the GUI, I can do some things like remove the ProPoint. I can click on this to be able to enable it and disable it. And when I do that, it's changing the behavior of that particular ProPoint. And when I run through the test case, in this case, it was expecting what the particular value was, and you can see that this value of cake, which I now changed to pi, pi was the expected one, supposed to be cake, is wrong because of the ProPoint that was there. So there I've injected a fault into the system, and maybe I'd like to create another test case where I check that error condition, right? But with the API, what I can do is all of the things that you just saw me do with the GUI, I can now do through the API, and I access that particular ProPoint by looking at the ID, which here that ProPoint has an ID of 2. And so I can enable and disable that ProPoint. I can delete it. I can change the value of it all through the API. So that's a quick one on how the ProPoints work in the API. I talked about coverage by component. So now with coverage by component, we've got components that are identified, and these components are built into and here we're doing the system testing, so we've switched over to VectorCAST QA, and within QA I can say which files are associated with the different components that I have in the system. And when I do that, I'm able to now run these components based on the tests that are associated with those files. So here I've got a database component, and for the database component I want to select initialize database as the test case that's associated with that. And then for the manager, I could say, look, all these other test cases are associated with the manager component. And then when I run that, it will run through the examples that are needed for that particular component. You can see that I'm getting the coverage information now just for that particular component and not for all of them. This would be useful, as I mentioned, if I had the example where I've got limited space on my target and I want to be able to run these tests and instrument only that particular component. So there only the manager was being tested, and I didn't test any of the features from the other component. So if I take manager then and say I want to run, the database component, say I want to run it, the initialize DB, now I can run those tests. And this can all be automated. I'm doing the clicks here just so that you can see how these pieces are put together. Okay, so that's coverage by component, allowing you to be able to run the different components and the test cases that are associated with those components in a incremental fashion to be able to reduce the amount of resources that are required on the target. Okay. So now we'll switch over to the last one, which is the coverage by component. So for coverage by component, we actually have an example of this built right into the delivery. So you can create, just run a script to be able to create this demo yourself. And with the component coverage, data control coverage, again, this is for DO-178C, and to have the ability to understand the couples that are associated with the components in the system. So for that, we've got this component editor, and that editor says what the components are and the files that are associated with that component. And with that, I can now run a static analysis on that and be able to understand what are the couples that are defined in the software between those components. And then once I've done all that, I can run through my tests. These are the tests over here. And when I run through each one of those tests, I can get a report that says how those couples were covered. So you can take a look at the test. You can take a look at all of the data couples that are defined within this on this system, all of the couples that are defined in the system, and then as I run through the tests, you can see all of the pieces for each test. So here, this is the correct test, and with the correct test, here are the data couples and control couples. Okay, and here's a incorrect test. Now with the incorrect test, you can see that I had this a read in the data file, but there was no write beforehand. So it flags it and says, hey, you should take a look at this. Why was it that there was a read to here before any write had occurred? So in this example, it's just showing you running through that static analysis, defining all of the couples that are in the system, and the report that's generated based on the requirements-based tests and how those couples are being covered. Okay, and I want to make sure there's time for questions, but last but not least, I can show you the Jenkins integration. If I can pull this over, yes, I can. So with the Jenkins integration, what we're doing here is we're pulling in all of the projects that are defined in VectorCAST and having the ability to run them in Jenkins themselves. And when you do that, it's nice because all of the artifacts actually come through onto Jenkins so that you can see all of the nice reports that get generated by VectorCAST. You can see them right within Jenkins. To be able to get coverage information here, I've only done one run, so there's only one data point here, but as I do this run over time, you'd see this graph fill up and be able to see the information about how your testing is progressing as you're doing the incremental software changes. Okay, and I think we've got time just to show you the website. This is the website live for you here, and here you can see the screen, what I showed a screenshot of, where 2018 is available, and you can see that we just released Service Pack 1, so Service Pack 1 is there. And here's the legacy builds. The latest build on the legacy now is 6.4.3. We're going to continue the 6.4 series for the next year, providing some updates. That's particularly for our Solaris customers. We want to make sure that they're getting updates for at least another year for the Solaris. Okay, Alicia, we're ready for questions.
Okay, great, Jeff. Thank you. All right. The first question is, let's see. When we say system test, the tests must happen on production code, which doesn't involve any tweaking the production code or mocking it. So how do we achieve the total system testing? Please clarify.
Sure. So when you run the tests, you can run the tests either instrumented or uninstrumented. If you're running them uninstrumented, then the information that you're getting back from the test are just the pass-fails. But if you need to also collect information about coverage, then an instrumented build is provided for the coverage. So it depends on what your testing objective is. If your objective is to collect pass-fail metrics, then you would run the uninstrumented version, which would be your production code. If you wanted to be able to collect the coverage information, however, then the instrumented version would be needed to be run, and that's how we get those breadcrumbs built into the code. And that harness is generated automatically, and we follow a process to create that harness. We know that it's generated correctly, and we follow a process for doing that, and that process is documented. So, but you're absolutely right. If you need to get coverage information on unaltered code, then that would be outside of the scope of what VectorCAST can do. But what you gain when you add that instrumentation is the ability to collect the coverage information of the code, and to have sophisticated coverage information as well, such as MCDC coverage information provided to you. Okay?
Okay, great, Jeff, thank you. The next question I have is, how can we do unit testing by using VectorCAST on target? Are there prerequisites?
Sure. So VectorCAST is built for being run on a target, and just as an operating system has a BSP to be able to adapt it to the environment that it's running in, VectorCAST also has an adaptation layer called an RSP. And that RSP is what's allowing you to do whatever the setup commands are, or all the special sauce that's required to run on the target environment, and to be able to collect the information back. If you're collecting coverage information, for instance, about how the coverage information is being about the coverage information. We can do that in several different ways. If the target board has a serial port, for instance, we can just get that information through the serial port. There's always a way to get information off the target to be able to find out the information about how the test ran. And that's what we do in the RSP. We do whatever is needed on that embedded target to get the information, and that way the rest of the system all works the same. So if you've got a test case and that test case runs on a target board, but you also want to run those same test cases on the host environment, you don't build two different harnesses. That's what VectorCAST will do automatically, and it allows you to keep those test cases consistent to each other. So if you make a change in the test case, you want to make sure that change is percolated throughout all of the environments in which that test case is applicable, and that's what the test automation platform is doing in VectorCAST.
All right, great.
Okay.
Thank you, Jeff. Okay, I think we have time for one more question. The rest of the questions, we will take and answer offline, so please keep them coming in, so we will definitely get to them offline. Okay, so the last question is, do you provide any fast way of doing the test harness? For example, automated.
I'm going to take a liberty with the question, and this may not have been what was intended, but with the testing harness, the harness is generated according to the type of coverage that you need to do. So if it's statement coverage, branch coverage, MCDC coverage. But we also have some special types of coverage as well. I mentioned probe points as already, and we have a special type of coverage that's called probe only. Now, with probe only, the instrumentation that we're adding to the test harness is only for the probe points themselves. So it's a very lightweight harness, and what you could do is, if you're collecting some information. Let's take the use case if you've got some debugging scenario, some runtime debugging scenario that you're trying to do, and you want to create a test harness for that. Well, create the probe points that you need to do this debugging, and then use the probe only coverage that will generate the test harness very quickly and allow you to collect the essential information that are needed in that use case. We're also doing, as I mentioned, one of the themes that we have for continuous is the ability to be able to do the instrumentation, even if it's full instrumentation, in a much more efficient way. And I guess I'll just say stay tuned on that, because we'll have some information about how we can do the full instrumentation in a more efficient way.
Okay, great.
Okay.
Thank you, Jeff. Okay, that's all the time that we have for today. Again, I'm going to stay on the line for a little while if you want to chat me over your questions, and we will get to them and contact you directly and answer them for you. I would like to thank you for joining us today for this webinar, and to let you know that we will be emailing each and every one of you a copy of a link to the recording of today's webinar. And if you would like more information about Vector and our products, please feel free to visit us at www.vector.com or at www.vectorcast.com. Thank you, Jeff.
Thank you, Alicia.
And everybody, thanks. And everybody have a good afternoon or evening. Thank you.